Robseco Future Farm. Today's innovations, tomorrow's solutions.
Welcome back to another week of Future Farm. I am your host, Trent Friesen, and I am joined here with our head agronomist, Todd Clausen, and we are here today to talk about traits. You know, when I think about growing up on the farm, I think about traded corn. I think it just seems like it's always been there. I have to go way back in my memory bank to think about a time where we didn't have traits.
Yeah. Well, if you're under 30 years old, you've had traits your entire life. The first in-plant insect protective trait commercially launched in 1996. Okay. Right? So, and that was an above ground trait. And think about how far we've come in 29 years. Today, or at least in 2024, 86% of all U.S. corn acres had a insect protected trait inside of it. And you think about, you know, that type of acreage, it's almost 80 million acres. So we've gone from an initial commercial launch of a single material to 86% of all acres in the U.S. having some level of in-plant protection.
Okay, talk about the different insect protection and different BT offerings. What kind of offerings do we have inside of a Robseco seed bag?
Yeah, good point. So at Robseco, we're offering at least 6 different above ground traits. Wow. And that's just above ground only. So if we'll keep this conversation to that perspective, we offer 6 different traits, and they come in multiple components. You know, we have Power Corn List, okay. We have BT Double Pro, we have Tricepta, we have AA, which is AgriSure Above, we have V, which is Viptera, then we have VZ, which is a second generation of the Viptera trait.
So there's 6 different traits. Are all the traits created equal?
Oh. No, so all these traits, all the components, they are naturally occurring soil bacterium. Okay? So you've heard BT, right? And BT is Bacillus thuringiensis. Okay. All the components of those 6 material and the components within those materials, they're all BT traits. Okay. Right? But no, they're not all created equal. When you think about the above ground insect control, the original commercialized BT trait was directed at European corn borer. Okay. And boy, today you just don't see corn borer because again, 86% of all the corn in the U.S. have a trait that will be somewhat effective on European corn borer. But those would be genes that are naturally occurring that are inserted into the genome or the DNA of the corn plant. When that corn plant gets to that part of the DNA, it will then express a protein in all tissue in the plant. Right? And so those tissue then, that protein is ingested by the larva and it ruptures their gut and they stop feeding. Right? So that's one, and those are known as the cry genes. If you've heard of cry.
Yeah, I was asking, I've heard that term, cry 1, cry 3. What is the cry gene?
Yeah, so cry genes, it has nothing to do with your tears.
Okay,
the cry genes have everything to do with, CRY comes out of crystal. Okay. They crystallize. So that protein, they all have to be ingested.
Okay.
So whether you're above ground or below ground, BT traits, they have to be fed upon. So you'll see some level of damage because they have to at least ingest that material for the protein to express. And so in the cry genes, they will be ingested, they'll come down into the midgut of the larva, and then they'll find their target site or what's known as the binding site. And all these BTs, all these different traits, all these different components of traits, they all have a different binding site. Okay? But the cry genes, they'll bind into the midgut, and then with the solution of the midgut, they'll start forming a multi-dimensional compound. And think about it as being all jagged and rough-edged. That ruptures the gut of the larva. Okay. They stop feeding, they die. Okay. So those are the cry genes, and those are the protein genes. And then we have another set that are still BTs, okay, that have a different type of binding site in the larva. And these are all larvae, they're all Lepidopteran species. Lepidoptera simply mean they're moth to egg to larva to pupa, back to moth again. Okay. Okay? But they serve as a protoxin. Again, they have to be ingested. Okay. But then they'll penetrate the cell wall, the cell membrane, they disintegrate the cell membrane, gut shrinks, they stop feeding. So no, all of these traits are not created equal.
So you want some sort of maybe different combination and whatnot to help get the best protection.
Yeah, and all of those, they are combinations. There are multiple gene traits, and that combination is very important.
Okay.
So you continue to mix and match, so you don't continue to select for resistance by any given species that's out there. So it's always important, whether you're above ground trait or below ground trait, to continue to rotate your actual traits. Hence why an organization like Rob Seco has the options and the flexibility to offer at least 6 different above ground traits. Does that make sense?
Yes, that's very important. Okay. Well, I know we've talked about, some of the below ground traits. I've had a chance to walk some fields lately throughout the Midwest and seen some larvae feeding on some ears. What's going on there?
So the ear feeders and the control of the ear feeders are a little bit different than those vegetative feeders. When I think about the vegetative feeders, European corn borer has always been #1. And so the ear feeders in this part of the U.S., and we're here in eastern Nebraska today, but we'll see these ear feeders, and they'd be earworm, corn earworm, and western bean cutworm. And they're completely different species. Corn earworm, in the central and northern corn belts, they don't overwinter here.
Okay.
They will come in from the far southern tip of the corn belt.
Okay.
So they'll come in with temperature, they'll come in with high winds, south winds, jet stream. So their moth will fly in this direction. So when they get here when they get here, I guess I should say, and it's all based on weather.
Okay.
But the corn earworm, what they want is they want to land in the tip. So they want fresh, active silk. So they'll land in the tip and they'll lay eggs right in the ear tip, right in the silk. Well, as soon as they hatch, where do you suppose those larvae go? They're already in there, right? And so historic methods of scouting and treating for corn earworm have been really futile, because once they're feeding larvae, they're in there and they're protected. And so if you're using foliar applied insecticide, your control is really, really dismal. Okay. And then the western bean cutworm are a little bit different animal. They overwinter as pupa in the soil below the soil surface. They'll come up and they'll lay eggs somewhere between V15, V16, V17 before VT, and they'll lay eggs on the vegetation. Then as soon as they hatch, they migrate towards the ear. They don't care if they're in the tip or not. You'll see western bean cutworm just bore right into the side of the ear. Right in the side. And people say, well, how do I tell the difference? If you've got corn earworm, you'll only have one in the ear. And I couldn't find any out here today, and I looked and looked and looked, but I do see a little bit of damage. But they're an extremely aggressive little animal. And if you pull them out of the ear tip, they'll turn right on you, and you'll just see their mandibles start to feed. But there'll only be one, because they're also cannibalistic. So they're very aggressive, very cannibalistic, and they do a lot of damage. Some of the, being an agronomist is kind of a lonely business. And I've always got that convenience store empty cup of coffee with me. When we find corn earworm, I'll always throw 2 or 3 into the same cup. 20 minutes later, there'll only be one. So just kind of the fun things that we get to do. But if you have western bean cutworm, they're very congenial. They're heavy feeders, and you'll see multiple in the plant at the same time.
So we talked about some of the damage with it. What kind of loss are you talking? How many? What's the bushel loss that we can expect, or where's it range?
So the loss stems from a number of different arenas. Number one, you have kernel loss. You absolutely have kernels that were fed on. They're lost. They're gone. Right. And consider if you're dropping 32,000 plants per acre, 3 kernels average on an ear loss would be a bushel. Only 3 kernels. And as I'm looking at these, there's not a lot of damage here, but you can see that you've got entry from western bean cutworm. But you have 1, 2, 3, 4, 5, 6, 7. There might be 7 to 10 to 11 kernels damaged here. And if that was on every ear, that'd be 2.5 bushel. Then secondarily, you have western bean cutworm that infected this plant down here in the mid part of the ear, and you see secondary diseases come in because you've opened up that kernel. You now have a pathway for entry of fungal pathogen, and then you can explode. And so not only do you have the physical damage, you'll get secondary damage from disease pressure. This happens to be Aspergillus, which can be a secondary problem because it will then produce aflatoxins if you're feeding it.
Okay.
But the difference between those vegetative Lepidoptera and the ear feeders takes a different protein, takes a different trait. So those material that work on European corn borer, they do have some suppression on the ear feeders. But what we utilize at Rob Seco, we have two, or actually three different traits that will control these ear feeders. Number one, it's V, or Viptera.
Okay.
Number two, it's a second generation of V known as VZ, which is a different combination of the Viptera with other genes incorporated. And then lastly, we have Tricepta.
Okay.
And those are our three directions for those type of larvae and that type of damage. This happens to be one of our Tricepta hybrids. And generally you see the Tricepta hybrid being extremely clean all the way around the tip.
Yeah, that's beautiful.
And these traits, these ear feeding Lepidoptera traits, they're black and white.
Okay.
They don't kind of work sometimes and kind of work others. They do control.
Okay.
Right to the row.
What kind of herbicide tolerance do these have?
Good point. Because we assume same herbicide resistance or tolerance across all these traits, and it's just not true.
Okay.
So when we think about the separation, you have glyphosate or Roundup, then you have glufosinate or Liberty, and you think, well, these will all have Liberty-linked tolerance, and no, they don't. The Viptera, the V, and the Viptera second generation, VZ, will be tolerant to Roundup and Liberty, but the Tricepta is not.
Okay. Was there anything else that you'd like to add?
I think they're tremendous traits all the way around. I think it's important to rotate your traits so we can continue to have efficacious ability from these traits so we don't lose their effectiveness. And lastly, you will see a lot of late planted material that can be much more at risk to corn earworm because they're going to find those later planted plants. They want that silk, they want that active silk, and so if you are 2 and 3 weeks later, if you're in a replant situation, you really need to watch what you're doing for corn earworm, and that type of direction, you may want to go to a Viptera, a VZ, or a Tricepta hybrid.
Okay, which again sounds like within a Rob Seco bag of corn, we have all the offerings and all the options to have some diversity to make sure that we don't get resistance. So that is very important and a good thing to have in a Rob Seco bag. So, Todd, thank you again for joining us, and thank you for joining us for another week of Future Farm.